Okay, the topics that we are going to cover in my class this year, or at least let's do this. We're going to be finishing the year 11 methods course this year in my year 10 class. We're going to be finishing a quarter of the year 11 spec course. That is what we do in year 10 maths. We cover year 11 methods. We cover year 11 spec, a bit of it. Now, I know some of you might be thinking that, but what about year 10 math? Majority of schools, the year 10 maths is pretty much the same as year 11 methods. Okay, year 10 maths is very, very similar to year 11 methods. So I'm going to tell you the topics that are in year 11 methods. This is a list of the topics in year 11 methods. All right. You don't have to write this if you don't want. It's just admin stuff or just. So there is a topic called functions. Functions has got the following things in it. It's got linear functions, quadratic functions, cubic functions, reciprocal functions, square root functions. Then a specific concept called domain and range of functions. All right, then another topic called relations. And specifically, relations include circles and sideways parabolas. That's one of the topics in year 11 methods. It takes an entire term for me to do that in year 11 methods. I spend one term doing that in year 11 methods. All righty. Another topic in year 11 methods is trigonometry. Trigonometry includes non-right angled trigonometry. Oh, by the way, it also includes right angle trigonometry. Has anyone got another way of saying right angle trigonometry very quickly, which is not a word? Yes, good work. SOHCAHTOA. Someone said it. Alrighty. So you do SOHCAHTOA, obviously. You do non-right angle trigonometry. All right. You do you do trigonometric equations. You do trigonometric equations. And when I say trigonometric equations, I'm specifically talking about stuff to do with unit circle. We do trigonometric identities. We do trigonometric graphs. That is also part of the trigonometric. That's part of the trigonometry topic, trigonometric graphs. All right. Third topic is called probability and counting techniques. Counting techniques is not 1, 2, 3, 4, like stuff like that. Counting techniques is something called like permutations and commutations, like number of arrangements and number of different. Yeah, so that's what it is. All right. Cool. That's probably just spares. Just pass them forward, pass the spares forward. All righty. Cool. All right. Probability and counting techniques. All right. Number 4. Topic number 4, it all comes in under the same thing. It's got indices. Topic 4 is indices. Exponential functions. So indices and exponential equations and functions. Topic number 5 is called sequences and series. And topic number 6 is called calculus. All right, what I've written on the board, which you don't have to write down, but what I've written on the board is a list of all of the year 11 methods topics. All right. Now, here's the thing. Every school does different stuff in year 10 maths. All right. Perth Mod does the year 11 methods syllabus in year 10 math. That's just what they do. Even the book that you buy is the year 11 methods book. So they have a bit of an advantage because they do year 11 methods in year 10 math. All righty. I'm going to tick the topics that are part of a normal school's year 10 course. This is part of a normal year 10 course. That is part of a normal year 10 math syllabus. Oh, by the way, I can't believe I forgot to write this. With trigonometry, there is something called radian measure. There is something called radian measure. You know how we measure angles in degrees? There's actually another way of measuring angles. It's called radians. All right, radian measure, whatever you want to call it, radians. All right. Every school does SOHCAHTOA in year 10. Everyone does non-right angle trigonometry. Everyone does actually trigonometric graphs and trigonometric equations. That's part of a normal year 10 math course. All right. Probability is part of a normal year 10 math course. Not counting techniques, but probabilities. Indices is part of a normal year 10 math course. All right. So what I've ticked in red is part of a normal school's year 10 math course. So I don't want everyone to be like, oh, we're doing year 11 methods of school. Yeah, we are, but that's pretty much year 10 maths. There's only one other topic in year 10 maths that you do that I don't do in class. And that's called like the finance section, the whole simple interest, compound interest, etc. That's also part of the year 10 math. I just don't do it, okay? Because it's not in year 11 and 12 methods or specialists. All right. Perth Mod, you guys are a funny school. All right. Yeah, you do well, but that's not because your school's good. All right. I think you do well because you're good. All right. So here's the thing. I know some people might think Perth Mod is an advantage. I'll tell you exactly what Perth Mod does. They do year 11 methods in year 10. Then they do year 11 methods again in year 11 methods. And then they do year 12 methods in year 12. Meaning Perth Mod does 2 years of stuff that doesn't count for ATAR. All right, you do 2 years of year 11, which doesn't even count towards your ATAR, and then you do year 12 just once. So I don't understand why you do year 11 methods twice. It would make more sense if you did year 11 in year 10 and you did year 12 in year 11 and you redo year 12. So every other school, don't worry. Perth Mod has an advantage at year 11, which doesn't count. All right. The other thing, Perth Mod, you do funny stuff. So knowing your school, you guys are going to start with functions first. That's where your Sadler book starts. This is how bad their school is. They follow the book. Now I'm going to be teaching you guys how to do this and this and this and this and something called transformation of functions. I'm going to be teaching you that. Once you learn all those things, then I will teach you how to do domain and range, because I'm going to tell you that you cannot do domain and range without knowing everything about all the functions. Your school's pretty bad. You guys will first do domain and range, then you'll learn the individual functions. That's how bad you are. So just wait for it. In school, your teacher will be like, all right, we're doing domain and range of functions, and you'll have no clue what each of the functions actually are. And then once you finish the test on domain and range, then your school will start teaching you the individual functions. All righty. So that's where my videos come in. All right, I'll have videos in advance of domain and range, because every kid tells me, Kunj, can we do domain and range first? No, we can't. We can't do domain and range unless we can do all the rest first. We can't do domain and range unless we do the other topics first. Okay. Cool. All right, and here's the other thing, Perth Mod. Do you know which of these topics is in year 12 methods? There's one topic here that's part of year 12 methods. Calculus. You don't do that in year 10. That's the one topic you don't do. The topic that's in year 12 itself. So don't worry, if you don't go to Perth Mod, you're not really disadvantaged at all. All right, they just do silly things twice that don't count. And the things that really matter, they just do the once. All right, great. Now, when are we doing what? All right, I'm going to highlight the stuff that's being done in term 1 with me. All right, this is being done in term 1 with me in week 1, actually. We're not doing SOHCAHTOA, that's last year. We're doing this today, non-right angle trigonometry. We're doing unit circle and radians. Sorry, we're doing unit circle next week. Radians next week. And then we're doing trig equations and trig identities the week after. That's why this booklet lasts us for 3 weeks. That is what we're doing for the next 3 weeks of class. All right, for the next 3 weeks of class, that is what we're doing. Then, week 4, we're doing linear. Week 5, 6, and 7, we are doing quadratic. Week 5, 6, 7, and 8, actually, we're doing quadratic. Week 9, we do cubic. And week 10, we do cubic. That is what we're doing this term. That is what we do in my class this term. All right. And then next term, we'll do like the reciprocal, square root, all this we'll do next term. And we'll do probability and counting techniques next term. We'll do this next term. Okay. So that's all next term stuff. All right. So we'll do up to 4. The only thing we will not do, this is like term 3 onwards. Okay, so we're going to do everything that I put in blue. That is the plan for this term. Now you have some idea what we're doing. Now, there'll be videos of everything, all right? There'll be videos on several topics. In case you need to know how to do domain and range of functions because your school's doing it, there'll be a video on that. In case your school's doing quadratics in week 1 and I'm not doing it till week 5, there'll be videos on that. So the videos will help you do topics that you're doing at school that I have not done yet with you or things that you might have forgotten. Great, that's my spiel done. All right, time to do today's booklet. And today's booklet is non-right angle trigonometry. All right, that is today's booklet, non-right angle trigonometry. All righty, let's write down some notes for and some of you have already done it with me. Some of you have already done non-right angle trigonometry with me, so you guys will find it easy. All right, here's my notes for non-right angle trigonometry. I'm actually just going to pull up last year's notes. So I don't have to write it again. Anything that I write on my iPad gets uploaded. So I'm not saying be lazy. That's not what I'm saying. Yeah, 10. All right, I'm not saying be lazy, but what I'm trying to say is in case you miss something that I write on the board, in case you do miss something that I'm going to write on the board, there will be a copy of that gets uploaded. All righty. So here are your notes for non-right angle trigonometry. This is your notes. All righty. And I'm going to go through each one separately. All righty. So first thing first, how do you label a triangle? In a triangle, we always label the sides with capital letters. All right. The sides get labeled with capital letters. What am I saying? The angles, you got to correct me if I say something wrong, okay? The angles get labeled with capital letters. All the angles get labeled using capital letters. All the sides get labeled using lowercase letters. And the way it works is always the side is opposite the angle. So if this is angle A, the side opposite is side A. If this is angle B, the side opposite is side B. All right, that's just the way it works. All right, there's always some silly kid that asks me, Kunj, why would they make it the opposite? It kind of makes sense because if that's A, you can't call the side next to it A because then it gets confusing because there's a side here and then there's a side there. And then how do we decide which of those is little a? So to avoid any confusion, it's the opposite side. That will be A. If this is side angle A, that is side A. All right, so that's just how we label triangles. All right, there are 3 rules. First rule is called sine rule. When do we use sine rule? If you have a side and the opposite angle. So if I was to label what each of the columns stand for, this column here is probably the most important column. This column here stands for when we use that rule. When do we use sine rule? That's what this column here stands for, when we use that rule. We will use sine rule. If you get given an angle in the opposite side, if you get given a side in the opposite angle, opposite side, you will use sine rule. All right. Sine rule simply says sine A on A equals sine B on B equals sine C on C. That's what the sine rule says. You can have it the other way around. You can write the sides on the top. You can write A on sine A equals B on sine B equals C on sine C. They both mean the same thing. All right. So Krish, one of the years, I taught the students, you can write the side on the top, you can write the angle on the top. Then what did one kid do in his final year exam? He did this. He said, Kunj said that you can have the sine of the angle on the top or you can have the side on the top. So what this kid did is he was doing sine of the side length divided by the angle. He was doing like sine 15 centimeters divided by 32 degrees because he thought that I said that you can flip the side and the angle. That's not what I meant. What I mean is you can flip this entire thing, but you can't be doing sine of a side length. You can do sine of an angle. Alrighty. That's not what when I say you can flip it, you don't do sine of 15 centimeters. That makes no sense. You only do sine of angles. Alrighty. How do you decide which of these to do? Anyone know when do you know which one to do? How do you know whether you do this version or when do you do that version? I mean, either or is correct, but what's the rule? Keep the unknown on the numerator. If a side is missing, if a side length is missing, I suggest you do it this way. If an angle is missing, I suggest you do it the other way. That's my quick rule. Unknown on the numerator. Keep the unknown on the numerator. Alrighty. Chris, do you reckon these formulas are on the data sheet? Yes, but I don't suggest you do it that way because sometimes is every single triangle that you're going to have, is it going to be A, B, and C in every triangle, or are some questions going to have P, Q, R and stuff like that? Yeah, I don't like doing it this way because some triangles might be P, Q, R and then you'll be like, oh, but my rule says sine A on A. Then they get confused. So I've got an English version of the rule. The English version of the rule is sine of the angle divided by the opposite side. That is my English version of the rule. Sine of the angle divided by the opposite side. It's a pretty easy rule to remember. I prefer the English rule actually. Sine of the angle divided by the opposite side. Can't mess that one up. That one's actually an easy one. It's the other next few that are a little bit trickier to remember, but that one's actually a pretty easy one to remember. Alrighty. Next rule. First of all, before I even tell you the rule, when do you use the rule? You use the rule if you get two sides and the angle in between. That's what included angle means, is the angle in between. We use the cosine rule if you have two sides and the angle in between, called the included angle. The cosine rule says a squared is b squared plus c squared minus 2bc cos a. That is technically the rule. That is technically the rule. Students are going to forget that rule. And what if the letters are not A, B, and C? What if the letters are P, Q, and R? Or what if side length C is missing? Then we've got to like rewrite this equation. For example, guys, if side length C is missing, the rule is actually C squared is A squared plus B squared minus 2AB cos C. Like the angles have changed. So what's the English way to memorize this rule so we don't mess it up? The English way to memorize this rule so we don't mess it up is this. The English way is this. Any side squared is the sum of the other two sides squared minus 2 times the product of the two sides times by cos of the opposite angle. That's the way that I'd rather you memorize it. Any side squared is the sum of the other two sides squared minus 2 times the product of the two sides times cos of the opposite angle. That's probably going to be easier. All right, Irina, you want to help me out? For example, let's say I want to work out R, okay? All righty. And it's unlikely that we've memorized this by now, but I don't want you to. I just want you to know the English version. So tell me, how do you work out R squared? Go for it. So sum of the other two sides. Yep, so go for it. So P squared plus Q squared minus 2 times P times Q times cos. That's great. That means angle. For those that don't get it, that means angle. All right, wasn't that much easier? R squared is Q squared because I said sum of the other two sides squared. All right. Minus 2 times the product of the two sides times cos of the opposite angle. You really can't mess it up. I'll tell you why. Some people will be like, oh, but Kunj, how do I know which two sides? How do I know what the other two sides are? Well, it's the side you don't have. It's not that one. Yeah? If anyone ever wonders that to find this missing side, how do I find out what the two other sides are? Well, I doubt you're going to confuse it with the one that you want. Because that's the one that you don't have. All right, it's the other two. And how many sides are in a triangle? 3. So it's pretty hard to mess up what the other two are if there's one missing side and the two other ones you know. All right, so that's the English version of the rule. Now, guys, you know how we rearrange equations to change the subject of the equation? You can rearrange an equation to change the subject. You can rearrange this equation so that it looks like this. It's the exact same equation, but it's been rearranged. So we actually use the cosine rule again, but when do we use it? If you have 3 sides. For the purpose of today, we're going to call this cosine rule version 1. We're going to call this cosine rule version 2 for the purpose of today. Version 1, version 2. Version 1 is if you have 2 sides and the angle in between. Version 2 is if you have all 3 sides. We use version 2 if you have all 3 sides. All right, version 2 is cos A is b squared plus c squared, take a squared on 2bc. That's technically the formula, but you might forget that. It's not like easy to memorize that one. So then I've got an English version of the rule, and the English version of the rule is this. The English version of the rule is cos of an angle is the sum of the 2 adjacent sides squared minus the opposite side squared divided by 2 times the adjacent sides. All right, so Aditya, for example, let's say I want to work out angle F. Yeah, I want to work out angle F. So what would be my rule? Cos angle F equals H squared plus G squared. All right, H squared plus G squared. Yep. Minus F squared. Cool. All divided by 2 times HG. See, the English version is so easy. See, he didn't use the rule. He just used the English version. Cos of any angle is the sum of the 2 adjacent sides squared minus the opposite side squared divided by 2 times the adjacent sides. So I prefer the English version like very much. All right, I very, very much prefer the English version. All right. So, yep, that is correct. That is correct. And lucky last rule. Lucky last rule. If you have 2 sides and the angle in between, I swear we've seen that before. Didn't we see that before? 2 sides and angle in between. So again, another rule with 2 sides and angle in between, but it's if you want to find out the area. There is a formula for area of a triangle. There is formula for area of a triangle. All you need is 2 sides and the angle in between. And the rule is half AB sine C. Or it can be anything. It could be like half BC sine A. Yeah, you can write half BC sine A if you want to, because what if you have these 2 sides and the angle in between? The rule is pretty straightforward. The English version of the rule is area equals half times by the 2 adjacent sides times by sine of the included angles. All right, so Sarah, give me one way to work out the area of this triangle. Give me one formula for the area of the triangle. Half y times z, yes? Sine x, excellent. That would be the area of the triangle, guys. Half y times z sine x, because that's the formula. Half times by the 2 sides times by sine of the angle in between. All right. Now, some of you did do it with me. I mean, we did this last year. This was a topic I did do with you guys last year. But just to remind you, everybody's done SOHCAHTOA. SOHCAHTOA applies in non-right angle triangles. Sorry. SOHCAHTOA applies in right angle triangles. That's what where SOHCAHTOA applies. It applies in right angled triangles. So my question is this. In a right angle triangle, one of the angles is 90 degrees, right? So how big can the other two be? They have to be less than 90. Everyone agreed you can't have more than a 90-degree angle in a right angle triangle because there's already a 90 degrees. If you already have a 90 degrees, you can't have something more than 90 degrees. All righty. But our topic now is non-right angle trigonometry. Technically, how big can an angle be in non-right angle trigonometry? It can be up to 180, right? Can you guys agree it can be up to 180 degrees? Like, for example, like hypothetically, this could be like 1 degree, and this could be 168 degrees. So now, because we're not doing because we're doing non-right angle trigonometry, angles can be as big as up to 180, technically. All right. So here's the deal, and I'll teach this to you in more detail when we do unit circle. All righty. I'm first going to give you the easy, if you're not so smart, the explanation, and if you're smart, the explanation. If you're not so smart, this is the rule. I'll explain it to you. Maybe some of you will get the explanation, maybe some of you will not, but for now, let's see what the rule is. If you're doing non-right angle trigonometry, and if you ever do inverse sine, if you're doing non-right angle trigonometry, and if you ever do inverse sine, your calculator will spit out an answer, but there is another answer. And the other answer is 180 minus whatever your calculator spits out. So you'll get an acute answer and you'll get a obtuse answer. There will be one acute answer and one obtuse answer. All right, there'll be one acute answer, one obtuse answer. And then what you have to do is check whether the obtuse angle fits. All right, I've just given you a rule. I haven't explained to you how it works. I've just given you a rule. And the rule that I've given you is that if you're doing non-right angle trigonometry, and if you ever do inverse sine, not inverse cos, not inverse tan, but if you do inverse cos, your answer is whatever your calculator gives you and 180 minus that. But then you have to check if the obtuse one fits. And that's specifically called something. It's called the ambiguous case. Now, those that are like decent at English, what does ambiguous mean? What does ambiguous mean? Like it's unclear. That's the point. If there's a certain question, there might be an acute answer, there might be an obtuse answer. All right. I actually want to explain that in a teeny bit more detail. And some of you have done it with me last year, but look over here. I want everyone to actually understand this. You don't have to draw this if you don't want to. You don't have to draw this if you don't want to, but if you want to, it's good to know. This is just explaining that second fact. So let me explain it to you in proper detail. It's a nice explanation. I like it. All right. So I've got a bunch of triangles here, and I'm just telling you that this and this are the same, okay? The two sides are the same. All right. Rubbed out that. And so there you go. Those are the two versions of the triangle. Whoops. Those are the two triangles that we have. Correct, guys? Something. Well, all righty. That's what I have. Something like that. Okay. I'm going to label this A, B, C. And again, A, B, C. And remember, guys, these two sides were the same. Yep, they were the same. You can see from the original picture, this and this were the same. All right, so here's the thing, Krish. Are these two angles the same? A and A, are they the same? Are these two sides the same? My entire class agrees that this and this are the same side length. This and this are the same angle. Is this the same in both of them? Yes, does everyone in the class agree that they're the same in both of them? There's all like that is equal to that is equal to that. Sorry, this is not the same, by the way. Sorry, I messed up one part. Is this the same as that? No, it's not, so I messed that. I wasn't meant to write that. I simply meant to write which two are the same. I was meant to write that these two are the same. That's what I was meant to write. These two are the same. Alrighty. So Krish, let's pretend I'm trying to find out what this angle here is. Is one clearly an acute angle? One's clearly acute and one's clearly obtuse. How would we find this angle, guys? What would be my working out? My working out would be sine C divided by, what's opposite that? Side length C equals, and technically I could say sine A divided by side length A. For those that don't get it, this is side length A and they're both the exact same size. For those that don't get it, this is side length C, they're both the exact same size. So here's the confusing thing, guys. Do both of these triangles have the exact same C? They have the exact same C. What do they also both have the exact same? Little a. What do they also have the exact same? Angle A. So they've got the exact same stuff. But clearly, how many different versions of angle C are there? Two versions. So what will happen is on your calc, you'll do this. You'll bring the C to the other side. So then you'll write C sine A divided by little a. Then you'll write C's inverse sine. And you'll do C sine A divided by A. But here's the thing. How many answers will your calculator spit out? When you do inverse sine of something on your calculator, how many answers does it give you? It just gives you the one answer. What's the angle that it gives you? An acute version. Dima, is acute the only thing it could be, or could it also be obtuse? It could also be obtuse, but the calculator is not giving it. The calculator is racist. Calculator is degreeist. It only gives you the acute angle. But is there another one that possibly does fit? Yes, and we all agree. What angle would that be? Because I'm sure everyone in the class agrees that this is the acute version, that's the obtuse version. I'm sure everyone in the class agrees that if this is x, if that angle there, or whatever, if I call this theta, can the class tell me what is this then? 180 minus theta, and being in an isosceles triangle over here, what's this one also then? 180 minus theta. I've just proven to you that when you do non-right angle trigonometry, the calculator only gives you the acute answer. How does the calculator know whether I've got this triangle or that triangle? It doesn't know because it's the exact same working out. So you always have to do, you'll get an acute answer, but then you also have to do 180 minus the acute answer to get the obtuse one, and you have to check whether the obtuse angle fits or not. Sometimes it does fit, sometimes it does not. All right. That's an explanation. If you don't understand the explanation, just do 180 minus that because I said so. All right. Cool. And if anyone wants one further explanation, you learn this more when we do unit circle. In unit circles, the x value always gives you the cos of the angle, and the y value always gives you the sine of an angle. So guys, if I told you sine theta equals a certain number, if I told you sine theta is a certain number, sine theta is like y, right? Do you guys realize that there are two possible angles that give you the exact same y value? This angle here gives you a certain y value, and this big angle 180 take theta also gives you that same y value. Do you guys see how there's an acute angle and an obtuse angle that give the exact same y value on a unit circle? Proving to you that when you do sine, there are two possible answers. Why isn't there two possible answers when you do inverse cos? Why is there not two possible answers when you do inverse cos? All right, cos is the what value in a unit circle? The x value. So let's say I told you cos theta is something or other. All right, let's say I said cos theta is a certain x value. All right, let's say the x value is like this one right here. Is there a particular angle here that gives us cos of that? And then there's an angle that goes all the way like this. How big is that angle? Like more than 270? Can you fit an angle more than 270 in a triangle? No, that's why you never have to worry about the ambiguous case for inverse cos. Yes, there are two possible answers for cos. Yes, there are two angles that cos of something gives you that value, but one angle is like way more than 270 and you can't fit, it's more than 180 at least, and you cannot fit more than 180 degrees in a triangle, so there is no ambiguous case for inverse cos. If you don't understand what I said for the last 5 minutes, you're going to remember this. I'm doing non-right angle trigonometry, and if I'm going to do inverse sine, I'm going to write down what the calculator says, and I'm going to write down 180 minus whatever the calculator says, and then I'll check if it fits. That's if you don't understand what I've been talking about for the last 5 minutes. Let's start today's sheet. All right. All right. So, the diagram shows triangle A. Yes? Yeah, go. Guys, I'm just going to pass a piece of paper around with a roll. Most of your names should be on there. If your name's not on there, I need your name, surname, and your number so that I can add you to the drive by this weekend. Okay? If your name's on there, just small tick. If it's not on there, name, surname, parents' number so that I can add you to the drive and add you to the enrollment. Most of you should be on there. All right. The diagram shows triangle ABC in which AB is 16. All right. Use a certain rule to find the length of AC. Which rule will I use? Now, I know it says use the sine rule, but why are we using the sine rule? We are using the sine rule, guys, because they give us an angle. You can clearly see that we have this angle right here, and we have the opposite side. And what rule do we use if you have an angle in the opposite side? We use the sine rule. All right. Are we trying to figure out a length or a side? What are we trying to figure out? Side. We're trying to figure out the length AC. And do you guys remember how I said keep the unknown on the bottom? It's always best to keep the unknown on the bottom because it just makes the algebra easier. So this is going to be my first line of working. AC divide by, some people will call it AC. What will other people call it? They'll call it B because it's opposite the B. All right. So some people will call it B. Some people call it AC, whatever you want to call it because it's, all right, whatever you want to call it. All righty. So AC divide by sine of the opposite angle, which is 118 degrees, equals, and now guys, pick another side and the opposite angle. Where do you have another side and the opposite angle? We have the 16 and the 26 degrees. So we write 16 divided by sine 26. Don't you dare do sine of 16 centimeters. That will get you completely wrong answer. Completely wrong. That's not what I meant when I said you can do it the other way around. All right, and now you just bring the sine 18 to the other side. So, sorry, sine 118 to the other side. So it's 16 sine 118 divided by sine 26. All right. I know it says significant figures and whatnot. That doesn't apply for in WA. WA doesn't use significant figures for math. So here's my rule for today. 2 decimal places for side lengths. 1 decimal place for angle. 2 dp for side lengths today, 1 dp for angle, unless it says otherwise. So can someone tell me what the answer is to 2 dp? Quickly, otherwise I don't finish the sheet. 32.223 then. I know it says 3 significant figures. Don't worry about that. In fact, 3 significant figures is actually 32.2. I'll teach you sig figs later. All right, but for now, 32.23 is what I want you to tell me. I'll explain to you what significant figures are. That's something we use in chemistry and physics. Chem and physics uses sig figs. Yes. All right, cool. All right, if you're not getting that, your calculator is in radians. You need to change your calculator to degrees. Oh, but is that correct, by the way? I just want to make sure her calculator is not in radians. Is that answer correct? Yeah, okay. If you're getting a different answer, you're either typing it in wrong because you have some neural problem, or you're in radians. If you don't show how to get it in degrees, ask the person next to you. If they don't know, it's the DRG button. All right, there's a button called degrees, radian, grad. Or for some of you, it's in the setup. If you're still stuck and the person next to you is stuck, then just call me over and I'll fix it to degrees for you. Okay, just put your hand up and I'll come across. All righty, question number 2. Use the sine rule. I hate how they keep telling us which rule to use. We're big boys and big girls. We don't need to be told. We have an angle and the opposite side. What do you do when you have an angle and the opposite side? We use sine rule. All right, what are we trying to find out? A missing side or a missing angle? We're trying to find out a missing angle. The missing angle is PRQ. Since I'm trying to figure out a missing angle, I'm just gonna write sine R. That's what I'll just write down because that's the angle R. I always like the unknown to be on the top. So since the angle's missing, I'm gonna write sine R. Sine R, what's opposite that one? 8.2. Divide by, and then you do the same thing. Sine of an angle divide by the opposite side. The only other angle and opposite side I have is that one there. So sine 57 divide by 11.4. I bring the 8.2 to the other side. I don't usually write this line of working. I'm only writing it because some of you are new. I usually will just jump to this line of working straight away. Inverse sine 8.2 sine 57 divide by 11.4. That's actually what we write down. All right. Oh shit, I'm doing inverse sine with non-right angle trigonometry. So as soon as I get an answer, what will I also do? 180 minus that. Why? Because I said so or because you understood so? Alrighty. So what's the said so one? What's the one that your calculator spits out? The racist acutest that it spits out? Anyone? Just to make today flow quicker, I'm just going to like copy last year because you guys are being slow. No, it's not even on this sheet. All right, someone just tell me, what is it? 37.1 or 180 take 37.1, which is how much? 143.9. But guys, sometimes the 143.9 doesn't fit. Sorry, 142. Sometimes the obtuse angle does not fit, guys. What's 142.9 plus 57? Does it go above 180? Yeah, okay, fine, reject it. There is a mark for considering it and then rejecting it. It didn't fit because there's already a 57 there, and 57 plus 140 is more than 180, so it can't fit. That's what I mean by check if it fits. All right, I've got a feeling it's going to fit in the next one. Why do I have a feeling it's going to fit? Let's read the question. In triangle ABC, all right, I'll draw it out. In triangle ABC, it doesn't have to be accurate or anything, okay? In triangle ABC, AB is 16.2, BC is 12.3, angle BAC is 37 degrees. I'm not sure which rule to use yet. I wonder which rule I will use. Well, it really does look like I've got an angle and the opposite side. So which rule I use? Sine rule. I'm trying to find out a missing angle. The missing angle is angle ACB. That's the missing angle. I've got a side and the opposite angle. Which rule do you use if you have a side and the opposite angle? We use the sine rule. So I'm going to write down sine, missing angle, I'll call it C, divide by the opposite side, which is 16.2, equals sine 37 on 12.3. Guys, I've got all sorts of useless kids that sometimes come to class. There are some kids that I see that write this, and then they write that. Because they said, Kun said you can write it the other way around. No, if you write it one way around for the first one, then you got to write the same way around for the second one. If you're going to write sine of the angle on the top for the first time, then you have to write sine of the angle on the top the second time on the other side. We bring the 16.2 across. I usually don't write this line of working. I usually just jump to the next one where I write inverse sine, but some of us don't get confused a little bit quickly. Inverse sine, 16.2 sine 37 degrees, divide 12.3. All righty, and that will give us the acute answer. What does your calculator spit out as the acute answer? Quickly, quickly. How much? Cool. So I'll write 51.5 for angles. And then what's 180 degrees? Take 51.5. 128.5, I think. All right. Does it fit? Does 128.5 fit? We'll check. Is 128.5 plus the 37 going to fit? Yeah, it does. Less than 180, so both are correct. I had a feeling that I was going to have two answers. The feeling was because the question said find two possible angles. Alrighty. It wouldn't always say that, but in that case, it did say it, so that just emphasized it further. Excellent. Alrighty. Question number 4. All right. Which rule should I use and why? Well, do you guys see a side in the opposite angle? I don't. In fact, what I see is two sides. Shh. And the angle in between. I also see it says use cosine rule. That helps. Alrighty. Have we memorized it? There's no point just reading your theory, like your notes sheet for the formula each time. What was the formula, guys, for missing side squared? This was version 1. This is cosine rule version 1. Any side squared is what? The sum of from memory was the sum of the adjacent side squared. So that was like 15.3 squared plus 7.8 squared. I used to tell everyone that the start of cosine rule starts like it sounds like Pythagoras. The first part of cosine rule looks like Pythagoras. One side squared is the other side squared plus the other side squared. But then there's like minus a bit. What was it then? Minus 2 times by one side next to it, times by the other side next to it. I had those two sides, times by cos of the angle in between. So cos 31.5 degrees. Yep, that was my working out. And there's always like 5% of the class that forgets to square root. And then they tell me that the side length is like 70. Or something big like that. Clearly, guys, it's not 70. Just use your eyes to realize that that's probably not 70 centimeters. All right. Once you square root it, what is xz? Anybody? What is xz? How much? Come on, guys. Today. I'm just gonna 9.56 centimeters. Great. That's your answer. That's using cosine rule. Great. Cosine rule version 1, actually. That's what it did. It used cosine rule version 1. All right. What about the next one, guys? We get given all 3 sides. What do you do when you get given all 3 sides? Use cosine rule version 2. Alrighty. Which angle do they want? They want sides of angle ACB. All right. I have to use cosine rule version 2. Cosine rule version 2 said cos of an angle is sum of the 2 adjacent sides squared. That's what I wrote in English. Sum of the 2 adjacent sides squared minus the sum of the opposite sides squared. So that's 18 squared. All right, sum of that, and then there was divide by something. Then there was divide by 2 times 13 times 17. And then I just jumped straight to the answer, but just because some of you are new, you do inverse cos. All right, Michael, do we have to worry about the ambiguous case for inverse cos? Do I have to do 180 minus whatever or not for cos? Not for cos, you're correct. All righty, and that's what we get. What do we get, guys? What's inverse cos of all that? One decimal, please, because it's an angle. One decimal place, come on. Anybody? Krish, what do you get? 72.4. C is 72.4. Pretty easy stuff. That's year 10 maths. Alrighty. Next one. All right. Find the length x. Oh no, they're not telling me which rule I should use. I'm going to have to think about it. All right. Well, they want me to find out x. I might as well just find out this missing angle, by the way, first, because it's easy to do. 180, take 32, take 40. That's like 70. That's 108 degrees. Alrighty, so which rule am I going to use? Well, I've got given an angle and the opposite side. I'm sure the class agrees that we have an angle and the opposite side. There's the side and there's the angle. We don't get given two sides and the angle in between. At no point do I get given two sides and the angle in between. Yes? Miss some of you guys? All right, so let's go for it. And I like to keep the unknown on the, I hope everyone realizes we're using sine rule because we have a sine angle in this opposite side. So it's easy if I just write x divides, what's opposite that one? 108. X divided by sine 108 degrees equals, and then I did the side on the top. So equals 23.1 divided by sine 40 degrees. Side divided by sine of the opposite angle equals side divided by sine of the opposite angle. We get the 101, 108 on the other side. So then we get 23.1 sine 108 degrees all over sine 40 degrees. Yes, anyone? Two decimal places? Quickly, quickly, quickly. Anybody? Quickly. 34.18 centimeters. X is 34.18. Everyone happy with that? I didn't do anything too hard. Side divided by the opposite angle equals side divided by the opposite angle. Always the opposite angle. So hopefully no one did sine 32 because you don't have the side opposite sine 32. Alrighty, next one. Which rule do I use if I have two sides and the angle in between? Cosine rule. All right, great. Two sides and the angle in between, we do cosine rule. Alrighty, so my working out simply says x squared equals 2.7 squared plus 3.8 squared. Just remember, cosine rule looks like Pythagoras for a bit. It looks like Pythagoras' theorem initially, and then there's minus some stuff. Minus 2 times 2.7 times 3.8 times cos 83 degrees. Don't forget to square root your answer, otherwise you'll give me a silly answer. What is x? How much? Anybody? Yeah? 4.38. Thank you. X is 4.38 meters. Easy stuff. Alrighty. If you're semi-bright, you're going to put the next question in notes because there's a learning point in the next question. There is a learning point, a very nice learning point in the next question. All right. So, first thing first. First thing first, which rule do you use? Someone said cosine, but I don't see two sides or the angle in between, nor do I get all three sides. So what rule do I use? Sine rule. Why do I use sine rule? Because I've got an angle and I've got the opposite side. If you have an angle in the opposite side, we use sine rule. All right. Now, I want to work out this side. I want to work out this side. But that sucks because to work out that side, do I need the angle opposite that? I don't even have the angle opposite that. So first, I'm going to have to work out this angle here. Why that one? Because that's the one opposite the 7.6. There's like no other information in there. So the first thing I'm going to have to do is do this. Sine theta divides 7.6 equals sine 61 degrees. Divide by 10.5. I bring the 7.6 to the other side, and then I do inverse sine. And Michael, what do I have to do when I do inverse sine in non-right angle trigonometry? Once I put into my calculator, what do I have to do? Yes, then you have to do 180 minus whatever you got, because what if that's the other answer? All right, so I'll wait for someone to give me the acute theta first. What's the acute version of theta? Anybody? Come on. 39.2, sure. Keep it exact in your calculator. And then what's 180 minus that? 39.3. And what's the other version? Or 180 minus 39.3, which is what? 40.7. Does it fit? No. That's save some time. Reject. Could it possibly have fit? Maybe, depending on the question, it could have fit. In this case, it did not fit. All right, we're not even done yet. That's not the question's asking. The question's asking to work out x. To work out x, I need the angle opposite the x. Yep. All right, you might be in rad. I'll come over and check. All right, let me come over and see. All righty. I'll come over. Now we find out this angle. Because angles have to add up to 180, we can find out that angle. All right. Phi is 180 degrees minus the 61 degrees minus the 39.3 degrees that you told me. Which is 1, no, it's not even 1. 79.7. All right. And finally, I can work out my missing side. Because now I have the angle opposite that. So, x divided by sine 79.7 equals and I need an angle in the opposite side. So 10.5 and 61 degrees, for example, equals 10.5 divided by sine 61 degrees. All right, I had to do 3 steps to do that question. That's one of the reasons why I wanted to put it in your notes. I bring the sine 79.7 to the other side. Who's got a final answer for me? 11.8? 1. Excellent. That's one of the reasons why I wanted it in your notes. Now, there's another reason why I wanted to put it in your notes. I'll tell you the other reason. And only the smart kids do this. School will not teach you this. Why did we use sine rule? Because I had an angle and the opposite side. Why did I not use cosine rule? Because I didn't have what? I didn't have 2 sides and the angle in between. Or I didn't have all 3 sides. But check this out. Guys, if I did use cosine rule and I was trying to find this side, which I already have, what would be your working out? If you're trying to find out this side, you'd be writing 10.5 squared, but you'd be writing x squared because you don't know what it is. And what would be writing, guys? What's the rule for any side squared? The sum of the 2 sides next to it. So what would you write? X squared plus 7.6 squared minus 2 times x times 7.6 times cos 61 degrees. And as a year 10 student, I would have a class pad. So rather than doing 3 lines of working, which takes forever, I'd be writing on my class pad 10.5 squared equals, what's the other side? One's x. What's the other one? 6.7, was it? 7.6. 7.6 squared minus 2 times x times 7.6. And I forgot what the angle in between was. Cos of what? 61. And I just make sure I'm in degrees. I'm in rad. Make sure I'm in decimal. And I put a solve in front of that. And I get 2 answers. Negative 4.44. All right. Did the ambiguous case work? Or did the ambiguous case get rejected? It got rejected. And this is the proof, the fact that one of the answers is negative. That shows to you that the ambiguous case didn't work. Otherwise, I'd get 2. If the ambiguous case did work, I'd get 2 possible positive answers. All right. And what do you notice the other answer is? 11.81. And did we get 11.81? We did. And how much faster was that? But only the smart kids know to do that. Only the smart kids know that that's what they have to do. The dumb kids just do it the boring vanilla way where they go, well, I've got a side in the opposite angle, so I have to do sine rule. But if you're smart enough, you'll realize that, hey, I could use my class pad and do it. All right. And if you get two positive answers, do you know what that means? It means that the ambiguous case did not get rejected. And therefore, the ambiguous case gave a particular answer and the non-ambiguous case gave an answer. All right. And that is your quick way of doing it. That makes sense? All right. So yes, my rules do apply, but if you have a class pad, you can sometimes get away with just doing it in one shot. And I'm sure everyone agrees that that took so much less working out than the other three, like writing all of the other stuff. That's why I want that particular question in your note page. That's the reason why I'm emphasizing that that question goes in your notes page. All righty. Next one. All righty. What I'm going to do is make 7 and 8 homework. So let's do the harder ones, 9, 10, 11, and 12. Joanne walks 4.2 miles on a bearing of 138 degrees. 4.2 miles on a bearing of 138 degrees. So she does this. This is such a vanilla question, yeah? So 4.2 miles on a bearing of 138. Students that have been with me for a while, students that have been to school should know that bearings start from north. All right, that's something you should know. Students that have been with me for a while, you'll know that I don't like writing 138 like that. I think it's messy. I'd rather you tell me how much this is or how much that is. But writing an entire 138, I feel is just unnecessary. So if that's 90, how much extra is that on top of that? 48 degrees? All right, so that's 48 degrees for 4.2 miles. And then she walks 7.8 miles on a bearing of 251 degrees. So I'll draw another compass point, 251 degrees. If you just know normal stuff, you should know that a bearing of 251 degrees, you got to go clockwise from north, 251 degrees. So that's north, but then 90, 180, 270, that's too far. So 250 is somewhere there-ish. How much does she go? 6.9 miles, so quite a bit. I try and make it look semi to scale. That's 6.9 miles. I think it's a very silly idea to write down 251 degrees. I think that's silly. I'd rather you tell me like this or this. Oh, sorry, I started reading the wrong question. You're right, 7.8. Sorry, I started reading 6.9 from question 10. Sorry, 7.8 on a bearing of 251. So 251 is almost 270. It's like 19 degrees shy of 270. All right, and what does the question now want? Question says, how far is Joanna from the point at where she started? Well, she's that far. So I'll call that X. All right, I'm sure everyone sees this Z right here. So that 48 degrees is right here. Meaning this entire angle is 67 degrees. All right. And what rule do you use if you have two sides and the angle in between? What rule do you use if you have two sides and the angle in between? Cosine rule. Two sides, the angle in between, we can go straight one shot and use cosine rule. So cosine rule says that x squared equals 7.8 squared plus 4.2 squared minus 2 times 7.8 times 4.2 times cos 67 degrees. Please don't forget to square root your answer, otherwise you'll get a silly answer, which makes no sense. All right, make sure we're focusing. Chris, some people here are new. They don't know like why they're here. Can you remind them why they're here? Some people forget. They think they're here to learn. Some people think they're here to learn. Some people think they're here to get smarter. Why are we actually here? Money, yes, to get rich. That's why we're here. We just need the good ATAR for the money bags. All right, being smart, you know, making your parent. I asked my GATE students, like I was teaching a GATE class a couple of days ago, and I asked, why are you here? And then one kid's like, to make our parents happy. I was like, no, that's not why you're here. You're here so we get an amazing ATAR, so we get money and we buy a big house, big car, big yacht, big wife. No, not hot wife, hot husband, whatever you're into. Okay, that's why we're here. All right, so next time you're not focusing, just think about waking up next to someone ugly for the rest of your life, and that might give you some motivation. All right, what do we get? X is what? 7.27 miles. Great. That's how far she's from the starting point. Find the direction in which Joanna would have to walk in order to return to the point where she started. Again, my students are pretty good at this. They want to know, guys, the bearing of this journey. They want to know the bearing of this journey to go back to the starting point. But my students know this. If I had to find out the bearing of this, that's messy. If I have to find out the bearing of this, then I got to like draw another thing here, and then I got to like work out what this angle here is. I think that's messy. I think it would be much easier. I think it would be so much easier rather than having to work out what this angle here is by working out this and working out this and working out that. I think it'd be much easier if I find out the bearing of this. Why would it be so easy to find out the bearing of this? I'll tell you why it'd be easy. All you have to do is work out this angle right here. And then that'd be so easy. You do 90 plus 48 plus theta, and then you know the bearing to go this. And students that have been with me for a while, what's another way of saying go back? Do a 180. Yes, isn't that another way of saying go back the other way? Do a 180. So once I get the bearing of this, I just either have to add or subtract 180 from my answer, depending on whether it's, that's what going the other way means. You do a bearing 180 degree opposite of what it is. So once I've got this angle, you either add or subtract 180 to your answer to find out the bearing to go back the other way. How do you know whether to add or subtract? If the number's really, really big, you subtract 180. If the number's small, like 20, 30, 40, 50 degrees, you add 180. All right, big numbers, you add 180. Small numbers, sorry, big numbers, you subtract 180. Small numbers, you add 180 to figure out. So rather than finding out the bearing to go this way, which seems like too much effort, I'm going to find out the bearing to just do what she did. And then because they want the bearing of the opposite journey, I'll just do 180 plus or minus that answer. Plus or minus away from that answer. So guys, I'll just use sine rule now. And sine rule says sine theta divide 7.8 equals sine 67 degrees divide by 7.27. Theta is inverse sine of that. And because I'm doing inverse sine, I better do 180 minus the answer and see if it fits. All right, who's got the acute version, by the way? Eighty-one point zero degrees or 180 degrees, take 81.0 degrees, which is 90, 99. All right. Is that the angle or just your eta? Okay, that's the angle. All right. Okay, 99.0 degrees. All right. Does it fit? All right. It does fit, doesn't it? All righty. 99 plus the 67 is still less than 180. All right. Now, this is not written in any textbook. I've never, ever seen it written. I've never, ever seen it written. And this is an amazing example for this. All right. I want to explain to you this. This is so important. Right now, guys, are there two angles that fit? Yes. All righty. Guys, do I technically have all three sides? All right. So what rule could I have used to work out this angle? Cosine rule. So cosine rule says this, cos theta equals 2. So I'm just going to work out theta another way using cosine rule. All right. I didn't realize that a question like this would come up. I was just hoping that this wouldn't come up, but it obviously has come up. So I'm going to do one side next to it squared plus the other side next to it squared minus the opposite side squared, divide by 2 times 7.27 times 4.2. And then can someone inverse cos that? There is an hugely important learning point that's not in any of the textbooks. You know what? I don't think even most of your teachers know this rule. All right, can someone tell me what theta is? I used sine rule, I used it correctly, and I got two answers because I had to consider the ambiguous case. Now I'm using cosine rule. What am I getting theta is? Don't forget you have to inverse cos the answer then. 81.0, only the one answer. And do we ever do inverse cos with, do we ever do inverse, do we ever do ambiguous case with inverse cos? No. All right. So this is confusing. Sine rule gave two legit answers. Cosine rule only gave the one answer. Now here's the rule that I've never seen in any textbook, but it's a rule. Always use cosine rule first if you can. Always use cosine rule first if you can. If you can't use cosine rule, then use sine rule. And then in sine rule, what is there obviously? The ambiguous case. Alrighty. Was it possible to use cosine rule in this case to find that angle? Yes. And I should have used that first straight away. The sine rule still gave the correct answer. It just gave another answer that, even though it did fit, it's not correct. So what's the rule that I've not seen in any book? Always use cosine rule if you can. If you can't use cosine rule, then refer to sine rule, and then you might need to consider the ambiguous case. Got it? Alrighty. Here's another way of telling you this. Michael, do we technically have all three sides? Then there's only one possible angle. If you have all three sides that are fixed, then the angle in the middle can't vary. Does everyone in the class get that? If you're one side fixed, another side fixed, how can the middle angle be two possible angles? It just doesn't make any sense. Alrighty, so the rule is if cosine rule can be used, it must be used first. Only use sine rule otherwise. Sine rule still did give the correct answer. By the way, we still haven't got the answer yet. That's just like, yeah, we still haven't got the answer. We need to first figure out, so what is this entire angle here, guys? What is the bearing from start to finish? From start to finish, the bearing is, well, this bearing was 138 plus the 81 degrees. So start to finish is 138 plus 81 degrees, which is 219 degrees. But I don't want start to finish. I want to go from finish back to start. What did I say you have to do to go the other way? You do a 180. You either add or subtract 180 to your answer to find out the bearing to go back the other way. So would you add or subtract 180 from 219? Subtract. The number's already pretty big. If you add 180, it goes more than 360. So from finish to start, 219, take away 130, what am I saying? 219, take away 180 degrees. And the answer is actually 39. All right, and I always write 3 decimal places. I write T to show it's a bearing. You don't have to write the T, but you do have to write the 0 in front because bearings always have 3 numbers. All righty, that's how I get the bearing. And we learned something there, that we use cosine rule if possible. We also learned that we need to be good with our bearings. All right, question number 11. Question number 11. Find the area of this triangle. All right, well, we can't do half base times height because there's no perpendicular height anywhere. So what rule do you use to find out the area of a triangle? Half times 2 sides times angle in between. Unfortunately, I don't have angle in between. Oh, I skipped 10, did I? Yeah, okay, 10's homework. 10's homework. Why not? It's like bare minimum questions for homework. All right. So guys, I need to first find the angle in between. What rule do I use to find the angle in between? Cosine rule. Let's first use cosine, and I can work out any angle. I don't care. You can work out A, you can work out B, you can work out C, you can work out whatever angle you want. I'll work out A. Why not? Cos A equals one side next to it squared minus the other side next to it squared. Sorry. Plus the other side next to it squared minus the opposite side squared, because that's what my English rule said. Add up the 2 sides next to it squared minus the opposite side squared. Divide by 2 times 10.4 times 11.0. All right, and then inverse cos that. Who's got A for me? Just give me 2 decimals for now because it's not the final answer. I'd rather have it accurate. 30.0? Just go 1 extra decimal. I'm happy with it for now. 0.7. I'm taking the extra decimal because it's not the answer yet. So I'm just using as... Ideally, I'll use the exact answer. And then I'll just drag it across on my class pad. You guys need to start bringing your class pad to class, okay? All right, that's why it's called a class pad. All right, area equals half times, what's the rule? Times the two sides next to it squared, so 10.4 and 11.0 times sine of the angle in between. But I won't be writing sine 30.07. I'll be writing sine ants. There is an ants button on your calculator. Ants copies the answer exactly from the previous line so that it doesn't carry through an error. If you have a class pad, you can write ants or you can drag it down onto the next line. All right, people that use this scientific calculator and they clear their calculator, not good. Stop clearing your calculator. You want to use the answer from before. So write ants. All right, who's got an answer for the area? Anybody? Answer? Two decimal places, area, come on. 28.66 centimeters squared. All right, that is your area. All right, we're getting pretty good at this. I'm just curious, who's never done this at school before? All right, oh, that's odd. Okay, fine. All right, now you know. Mod, did you do sine rule, cosine rule in school in year 9? Yeah, okay. Some schools do it. All righty, next one. The diagram shows triangle XYZ, in which XY is 22.5. Angle XYZ is 30. Okay, everything's there. Find the length XZ. Alrighty. Well, first thing first, they've told me the area is 100. So I'm going to use the area formula. But if I use the area formula, guys, then area only works if you have two sides of the angle in between. So first, I'm going to use the area formula, and I'm going to work out what YZ is. So area equals, so the area is 100. So 100 equals half. 100 equals half times 22.5 times YZ times sine 34 degrees. First, I have to figure out what YZ is. All right, I hope everyone realizes that I've got two sides and the angle in between. So I'm not using sine rule, I'm using the area formula. Some people might be thinking, Kunj, why are you using the sine rule? I'm not using the sine rule, I'm using the area formula. The area formula is half times two sides times sine of the angle in between. All right, 100 is this. Then you just have to bring the 100 to the other side, the 22.5 to the other side, and sine 34 to the other side. If you have like zero math skills, you have to do 100 divided by half times 22.5 times sine 34. If you have a class pad, it will do it automatically for you. If you don't have a class pad, make sure that's in brackets. Otherwise, it wouldn't do the BIMDAS properly. All right, make sure that's bracketed if you're using a scientific calculator and not using the fraction symbol. And you've got a YZ. Quickly, I've got 1 minute left, less than 1 minute. What's YZ? Anyone? How much? Just trust me, or trust yourself and give me an answer. 15.9? 9 what? It's actually 15.8. 89? 895. So say 90. So then I know it's two decimals. But yeah, 15.90. All right. Come on, guys. Some of you have to be a little bit like clear. If a lot of you want to be a doctor, you can't tell a patient, oh, you have cancer. Yeah, they don't get it. You have to be clear. You have cancer. Be clear. All right. Don't want to be like, yeah, then they get confused. All right. Be clear. All righty. 15.895. All right. That's not what the question wants. The question wants the length of XZ. What rule do I use now to figure out that now that I've got these two sides? Now I use the cosine rule. XZ squared equals 22.5 squared plus ants squared. I hope everyone in the class is writing ants squared and not 15.90 because that's been rounded. So then you're going to write ants squared minus 2 times 22.5 times ants times cos 34. Everyone should be writing ants. You're not going to be using a rounded value because it just carries through the error. All right, so I'm using cosine rule. XZ squared is 22.5 squared plus ants squared minus 2 times 22.5 times ants times cos 34. Don't forget to square root. What do I get xz is? Come on, I'm 1 minute over. How much is xz? Come on, guys. Almost. I'm already into science time. I got to start. xz is? All right, come on. There's so many Asians here. Use your piano skills and type on your... What's the point of learning piano if you can't type on your calculator quickly? Come on. What do we have? 12.88. Excellent. Are we happy with that? All righty. I'll be sharing the drive with you. The drive includes fully worked solutions to the booklets. All right. All done. Science time.